Are you certain that you are living in the present moment? What if the past, the present, and the future all exist right now, simultaneously, side by side? It sounds like a paradox. Yet this isn't the fantasy of a philosopher. It is a direct consequence of the very equations that govern our universe. Albert Einstein, the father of relativity, famously described the distinction between past, present, and future as only a stubbornly persistent illusion. Imagine opening a book. Every page already exists, from the first chapter to the last. You simply experience them one page at a time. What if the universe works exactly like that? What if time is not a river carrying us forward, but a vast landscape that we move across, one step after another? Today, we'll explore one of the most extraordinary ideas in modern physics, a theory suggesting that the past never truly disappears, and that the future already exists somewhere, waiting to be reached. To understand this idea, we must begin with one of the greatest scientific discoveries of the 20th century, Einstein's theory of relativity. Einstein revealed that space and time are not separate entities. Together, they form a single, four-dimensional fabric known as spacetime. If spacetime is one unified structure, then time should be treated just like length, width, and height, not as something that flows, but as another dimension through which reality is arranged. And if time is truly a dimension rather than a moving stream, then the past and the future should exist just as objectively as the present moment. Physicists call this concept the block universe. According to this view, the entire history of the cosmos, from the Big Bang to its unimaginably distant future, already exists as a complete four-dimensional structure. Instead of reality being continuously created moment by moment, every event may already occupy its own permanent place within the fabric of space-time. Our experience of moving through time could simply be the way our consciousness travels across this enormous cosmic structure. If this theory is true, then the dinosaurs never truly disappeared. They still exist, just in a different region of the cosmic block, as real as you are at this very moment. The events that will take place 1,000 years after your death may already exist as well. You simply haven't reached those pages of the story yet. This completely transforms our understanding of death. If the past never vanishes, then the moments of your life never truly come to an end. Every conversation you've ever had, every sunrise you've ever witnessed, every heartbeat you've ever felt continues to exist forever, fixed within its own location in space-time. That idea can feel deeply comforting, but it also raises a disturbing question. If the future already exists, are we truly free to make our own choices? If tomorrow has already been written into the structure of the universe, did you ever really have the freedom to choose differently? This question has divided physicists and philosophers for decades. Some argue that the block universe does not eliminate free will. It simply changes what freedom actually means. Your decisions are still your own. They are simply part of the timeless structure of reality, existing exactly where and when you make them. Others strongly disagree. If the future already exists, then the very idea of choice may be nothing more than an illusion created by our limited perspective. This debate is known as the problem of determinism, and despite centuries of discussion, no consensus has ever been reached. But what if physics itself has already offered us a clue? Not through philosophical arguments, but through some of the strangest experiments ever performed. In laboratories around the world, quantum experiments have produced results so counterintuitive that they seem to challenge our deepest assumptions about the nature of time itself. Some scientists believe these experiments may hint that reality is far stranger than our everyday experience suggests. Quantum physics has revealed experiments that seem to suggest something extraordinary, that the future may be capable of influencing the past. One of the most famous examples is known as the delayed choice experiment. Its results are so strange that even many physicists struggle to fully accept what they appear to imply. A decision made by the scientist in the present seems to determine how a particle behaved a fraction of a second earlier, before that decision was ever made. If time truly flows in a single linear direction, such an outcome should be impossible. But if time is not a flowing river, but a fixed four-dimensional structure, these bizarre results begin to make a surprising kind of sense. Perhaps these quantum experiments are not anomalies at all. Perhaps they are our first glimpse into a reality where time has never actually flowed, and where every event simply exists within the timeless architecture of the universe. But if time doesn't flow, why does it feel so real? Why does the past seem fixed while the future remains unknown? Some physicists believe that the sensation of time passing is not a property of the universe itself. Instead, it is created by the way our brains process information. Your brain remembers the past, but it does not remember the future. That asymmetry of memory creates the powerful illusion of a direction in time, a direction that may not exist outside our own perception. Imagine reading a novel. The story feels as though it unfolds page by page, yet every chapter already exists from the moment the book is printed. Perhaps reality works the same way. Time never moves. Instead, it is our consciousness that moves through an already complete space-time landscape, giving rise to the feeling that moments are continuously appearing and disappearing. In other words, the flow of time may not be a feature of the universe at all. It may simply be the way a conscious mind experiences an eternal, unchanging reality. Not every scientist agrees with this picture. Many physicists argue that time truly does flow, and that its passage is one of the most fundamental features of reality itself. Their strongest argument is entropy. The universe constantly evolves from order toward disorder, and this irreversible process appears to define a clear direction in time. A shattered glass never spontaneously reassembles itself. Smoke never returns neatly to the candle. These irreversible events form what scientists call the arrow of time. If the universe were nothing more than a frozen four-dimensional structure, why would nature obey such a strict rule of increasing disorder? The debate remains unresolved. Some researchers believe the answer lies beyond quantum mechanics and relativity, in a deeper theory that has yet to be discovered. In fact, a growing number of physicists suggest something even more radical. Perhaps time itself is not fundamental. Maybe what we call time emerges from something far more basic, in the same way that temperature emerges from the motion of countless individual atoms. This idea appears in one of the most ambitious areas of modern physics: quantum gravity. Several leading theories attempting to unite quantum mechanics with general relativity produce a surprising result. At the deepest mathematical level, time simply disappears. It is no longer a fundamental variable in the equations describing reality. To many scientists, this is one of the most astonishing discoveries in theoretical physics. The universe itself may not require time in order to exist. If that is true, then asking, "When did time begin?" could be as meaningless as asking, "What lies north of the North Pole?" The question assumes something that may not actually exist in the way we imagine. Perhaps this is what makes time such an enduring mystery. Every new discovery seems to challenge our intuition, suggesting that reality is far stranger than our everyday experience allows us to perceive. And perhaps the deeper we explore the nature of time, the closer we come to realizing that the greatest mystery was never time itself, but the limits of human understanding. What would this mean for you personally? If the block universe is real, then every joyful moment of your life exists forever. The embrace of someone you love, the laughter of your child, the quiet peace of a morning you never wanted to end. None of those moments truly disappear. They remain permanently woven into the fabric of space-time. This changes the very meaning of loss. Perhaps nothing is ever completely gone. It simply remains in a region of the universe that we can no longer reach. That is why the idea of the block universe is both comforting and unsettling. It offers a kind of eternity, yet it challenges our deepest intuition that life is constantly moving forward. But perhaps the real question is not whether time flows. Perhaps what truly matters is that every moment you live becomes an everlasting part of something far greater than yourself. So does time actually pass, or does it simply exist all at once? Modern physics has not yet given us a definitive answer. But the search for that answer has already transformed the way we understand reality itself. If time is a frozen structure, then this very moment, the one in which you are listening to these words, will exist forever, preserved somewhere within the timeless fabric of the universe. Perhaps that is what eternity truly means. Not an endless continuation into the future, but the fact that every moment remains permanently real. And perhaps that is why we continue asking this question, not simply to discover whether time flows, but to understand what it truly means to exist within it. Every day, physicists take another small step towards solving this extraordinary mystery. Somewhere, at this very moment, someone may be writing an equation that brings us closer to the answer than ever before. Or perhaps the answer will never come. Perhaps the nature of time will forever remain the boundary where physics meets the deepest mystery of human existence. Whether time flows or not, one thing is certain. The moment you have just experienced has already become an eternal part of the universe. And perhaps that is the only kind of forever any of us will ever need.